Joining me is Julia Guerra with FlyGuys.
Tell me a little bit about yourself, and of course, the reason you're here is because of Fly Guys. Who are they? What do they do? How do they help the construction industry?
Absolutely. So FlyGuys is a reality data capture network, meaning that there is a multitude of Part 107 pilots, reality capture specialists across the United States and a few other areas across the world, where we can provide and collect data in a variety of means. As far as myself goes, my background is in architecture. My education is in architecture. I went to Kansas State for my master's and immediately defected to construction. I realized that it was not made for me. I was not as much of a designer as I was an implementer. And going directly into construction really gave me that conversational component of being able to communicate from the design side and draw that bridge into constructability.
Well, I suspect a number of members of my audience will be pleased to hear that you defected over to the construction side. So well done, you. There are a whole bunch of different technologies that are involved. So I don't know if this is the best place to ask about that, and you will guide me, but perhaps just some of the technologies that are available that can be attached to drones.
Absolutely. Some of the most standard technology that's been around for the last 10 years would be, just a regular photo camera. We used to just go up. One of my first jobs about 10 years ago with a drone, we were going up as high as we legally could, and we're taking direct down pictures of the site so that we could stitch them together in a flat map. Now we're in a situation where we have automated flight mapping with high fidelity RGB cameras that can then stitch into an orthomosaic. The next tier up, I would say, would be LiDAR. So that is using lasers instead of photos to detect the ground plane or any other materials content. My initial broach into drones was through RGB and actually thermal. I was doing some horizontal construction with the solar field. And the question was, can we just take pictures with the thermal camera and make it quite a bit faster? And the answer was yes. So I would say the three standards are probably, RGB photos, thermal photos, and LiDAR as far as payloads being carried by a drone on a standard basis scaled across the United States and otherwise.
Expensive job site mistakes that drones, and if someone is employing a qualified drone pilot, and we'll get to what makes a qualified drone pilot soon, but what sort of mistakes can be found, and how does that early detection help the constructor save time and money?
Well, I think that we all know in the field that nothing is ever quite as it seems on a design sheet. We're often designing in a dollhouse mode, in a vacuum of sorts. So I would say the first preventative mistake is using that data for design. When you have an informed design from the reality of the environment, that design intent can shift according to what the context is, which inherently provides a better constructability option for the individual creating it in the field. I would say that at the time that even before you send a survey crew out to do an Alta survey, or maybe even before you take possession of a site, the fidelity of the data that you're capturing not only shows you the topography, potential erosion, it also might show environmental implications, unsuitable soil seams, different typologies of animals, plants that need to be protected. I can't tell you the number of times that I've been out on a job where the entire team is deployed. We have several hundred people out there, and the entire job gets shut down by a gopher tortoise or a bird. I can't tell you the cost of that mistake is enormous, and it happens. So number one would be catching it before we even get out there, before the contractor's even selected, so the designer is making appropriate decisions. But I would say that the largest saving is safety. Anytime that someone doesn't have to work at height, anytime that we can avoid putting people in a precarious situation where we could just have an image of an inspection, that is always the greatest saving and the greatest mistake saver that you could possibly ask for. Looking at a power pole or assets on different poles, rooftops, rooftop units. We don't have to put someone in a harness. We don't have to put someone at height. That's absolutely number one. But I would say one of the tangible things that people can find to their pocketbook in the field is consistency. The conversation changes when you're going from who installed what where and why did they do it and whose drawing was last or first. The entire conversation changes when everyone comes into the room and we say, we saw that it was installed at this elevation at this time, to, okay, now what do we do? Instead of the he said, she said that often happens in a job site trailer, everyone comes to the same playing field and the communication field is far cleaner when you're just, speaking from the same sheet of music on a consistent basis.
In job site trailers, those conversations can be quite imaginative and exciting at times.
Spicy. They can be spicy.
So just looking at it from the contractor, specifically from the contractor's perspective, what do you find, and have you found, what surprises general contractors the most, or perhaps what assumptions about their schedules time and time again prove to be wrong?
It's a great question. Well, I would say most GCs are looking at their site from the sky every day, right? There's a 46-inch printout on the wall, and they're looking at their site plan every single day. I can't tell you how comprehensively different it is when you're looking at that with the true elements in picture. The scale and the understanding of the flow of your site, your schedule, is a complete shift from looking at a site plan that's maybe variable from a design intent to your true environment with, elevation, altitudes, and existing conditions. I would say, regardless of what you're getting out of that view from above, you're getting it quicker. You are getting it immediately within 24 hours of a flight. If I have a 100-acre site, I can fly that, process it, and have a DTM or a terrain map for someone within 24 hours. More importantly, it's about the integration of that overhead data into their process and workflows. I find that the most successful GCs that I've worked with or worked for find a way to integrate that data into their day-to-day so that it's not, kind of siloed into the VDC or the digital world. Like, for example, McCown Gordon Construction has an API from drone deploy to Procore. So the pilot goes out on site, he flies the map. That map is on the homepage of Procore every day for every inspector, QC person. No one needs special access. We can see the existing conditions, and I can say, hey, he didn't get an approval for that section, and they already dug that, and we need to go talk to that guy right now. I find that, integrating into ACC, Procore, AConnex, Innate, just putting it into your tools that already exist. The intent isn't to shift everything away from what your day-to-day is. You're already looking at that site plan. You're already doing your day-to-day workflow of your, change orders and specs and scoping and, contractor meetings. I find that the most beneficial and most powerful element is when that's just another page in the book, another slide on the slide deck that that you have weekly consistent flights or whatever that might be. It just brings everybody together on the same sheet of music.
Now, earlier you had talked about thermography in relation to solar panels or a solar installation, but how is aerial data changing quality control in construction? But also, are there still some things that you do require boots on the ground to ensure quality control?
Well, with your thermal use case, I would say in my own experience, I was on a 200 megawatt, maybe 1,400-acre site. And in that scenario, our QC team was going to truly evaluate maybe 15% of the panels. If you see an issue, a discrepancy, power outage, then you can kind of go to an area and treat that area. Um, but you're not getting ahead of it. You're not adjusting anything and you're not understanding what your true efficiencies are. We went from 10 and 15% of a 200 megawatt site to 100% 10 times. So the QC team, instead of having to go out to each individual one and check and say, okay, is this the bad egg? Is this the bad egg? Is this the bad stringer? Is it this panel? What's the root cause of this power shortage or a power exceedance? They can quickly see it with their eyeballs, or even better, analytics software. 10,000 photos could be a bit cumbersome, especially when they all look the same. Feeding that into an AI data analytics software is definitely the way to go. It identified all of the issues that they needed to treat. And then to your second question, yes, then they go out and do boots on the ground as they would, but with more strategic information on the front end.
we talked about the technology that goes up in the air, and either through thermography or just regular photography, LiDAR, it's gathering data. What is it on the back end? What sort of software? What sort of AI? What sort of
The
cool things
analytics.
can that technology now
Mhm.
bring to all the raw data that's collected by the drone and the drone operator?
I would say that without that software, without the different analytics options or place to view it, then you're not really getting a whole lot out of it. Some of the big names, Autodesk and Procore and all them, they don't necessarily have a purpose-built scenario within the reality data capture to truly analyze the bells and whistles of the actual data. There are some really exciting AI softwares out there that are purpose-built for a specific item. I would say that dependent on exactly what you're doing, there is a purpose-built solution out there. The caveat of that is that this is a very snake oil salesman type world. It's an exciting new world, meaning that everybody and their mom is trying to figure out if they can make a quick buck. So my recommendation for looking for those analytics softwares is obviously, stay aware, get on LinkedIn and news like articles like yourself. But at the end of the day, talk to someone because unless you get a little peek into behind the curtain, you're not really going to know what you're getting. And there's a lot of really incredible options out there.
So I'm a GC, a construction manager. I've got this project that I'm building. I want to get drone technology in my pocket. I want to bring it to bear on this project so I can avoid problems and get all this really cool information. How do I go about doing that? What am I looking for?
Well, in my opinion, I think the easiest path forward for anybody is to just call us. But as somebody who was building their own internal drone teams, I would say number one is culture, work ethic, integrity. You're out there in the field, things are highly variable. There's a lot of automated processes. People can get away with a lot. It's so important that your person is incredibly vigilant in the field. This is a major piece of equipment. It can be dangerous. If they understand and comprehend that, that's usually a really good indication that they're not just a hobbyist, they're actually a careers person. And then a sample data set. There's a lot you can't see from a phone conversation, an interview, an email. That everything might look really good until you go out and you set up with someone in the field and watch their process. If they start with a pre-flight checklist and a JHA and appropriately setting everything up, or if they're opening their doors and on the phone and running around, there's two different worlds. There's the people who are out there just flying, and there's the people who are really making this the true industry that it should be.
And one more thing, if I heard you correctly, right at the very start of our conversation, I think you said Part 107 pilots. So
Hmm.
what does that mean to be a Part 107 pilot?
That's a great question. So, obviously, anyone can fly a drone and put it in the air, but aircraft are regulated by the FAA. So, if you're flying a drone for any commercial purposes, you're required to have a Part 107 license, meaning you go to a testing facility, you take an in person test, it's all on paper, and then you get a card that you renew every 2 years. But once you have that Part 107, you are capable and able to run your own commercial operations with the UAV.
So as I understand it, we've got some really good information here if someone wants to develop their own in-house team. But then, of course, if they need experts and they don't have the time, money, inclination, what have you, they can always reach out to Fly Guys to find qualified drone experts near their project.
Absolutely. I mean, I met FlyGuys when I was at a different construction company, maybe 500 people. I was the main drone pilot and I was deploying my own team, so I had no interest in using FlyGuys at that time. Then my next company had 10,000 people and was nationwide. And I was like, oh dear Lord, how will I ever do this by myself? And I myself started partnering with FlyGuys.
You did not mention at the beginning of this conversation that you were also a drone operator. Are you keeping up with it? Do you have your Part 107?
I do. I actually just flew a job a couple days ago, a little one. But yes, I initially started mostly flying my own and then transitioned into mostly training folks. Yeah, I love flying, love getting in the air. I miss being out in the field more. I spend too much time at my desk now.
Well, Julia, thank you for taking the time to talk about all the different ways that drone technology as it stands today, plus all the data and analytics that come with it. So I really appreciate you taking the time.
Yeah, likewise. Thank you so much, Anthony. It's been a pleasure.